Hello, welcome to lesson 1A on notation and naming conventions. In this lesson, we're going to learn about how to identify, name, and classify a point, line, angles, planes, segments, rays, lengths of line segments, and measures of angles, parallel lines, congruent figures, and how to mark diagrams. So, why are we doing this? One, this is probably the longest video we have all year just because this is all very basic stuff, but you just got to know it. In geometry, it's really important to use proper notation. It's like proper punctuation. If I use the wrong punctuation, like in this sentence here, it's really hard to read it. So in this class, you need to be using proper notation at all times, because even a slight difference in the order of letters or in what type of symbol you use can indicate an entirely different object in a diagram. The first thing we're talking about are points, and points are one of our three undefined terms. Points are named with a single uppercase letter. So for example, if I have a point here, I would name it point A, and I can define where they are. So for example, point A lies between point C and D. The letters have to be unique. There can only be one point A in a diagram, for example. So if I've got this picture here and I label this guy A and this guy B and this point off here A again, that's not okay because we only have one A in the diagram. We draw a dot to represent an important point and we label it with its name. You don't need to draw a dot if it's an obvious intersection. So for example, if I've got two lines intersecting like this, I can label this D. However, one thing I cannot do is I can never label an arrow as a point. So if I come over here and I label this guy C with no dot, that's not okay. So the next type of term we have are lines. Lines are, again, one of our three undefined terms. And lines are named by naming 2 points on the line. So, for example, if I've got a line here, and this is point A and point B, I would call this AB, and I'd put a arrow over the top of it with 2 arrows on either side to indicate that it's a line. We could also name this line BA. It means the same thing. If I throw another point on here, point C, I could name this CA or AC or BC or CB. All those are okay. One thing I cannot do, I cannot name it ABC. That is thoroughly not okay. It's 2 points, never 3 points. Since a line contains an infinite number of points, there are infinitely many names for a single line. Sometimes in a diagram, you'll see a single cursive lowercase letter. So for example, if I call this L, so I could call this then line L. It's another way to name this line. But we always say the word line followed by the lowercase letter. We always draw an angle at both ends of the line to indicate that the line extends to infinity. Otherwise, it might be a ray or a segment if we don't draw those arrows. All right, planes are our last of our three undefined terms. And we name a plane by naming 3 non-collinear points that lie in that plane. That word non-collinear is really important. That means not on the same line. So for example, if I've got a plane, we always designate planes by drawing vaguely parallelogram-esque shapes, where this is A, B, C, D, and I'm going to put another point here, E, where C, D, and E are on a line together. I could name this plane ABC, ABD, ADE. All of these things are good, but I cannot name it, not name it by the 3 collinear points CDE. So we cannot do by the 3 collinear points, but we can do it by non-collinear points. So sometimes the plane in the diagram will be labeled with a single uppercase cursive letter. So for example, if I had this here labeled as plane M, uppercase cursive, we could also name this guy plane uppercase cursive M. So those are our ways to name a plane. It's always named by 3 letters, not 2, not 4, always 3 non-collinear points. Our next term is array, and we name array by naming its endpoint followed by another point on the ray in the direction of the ray. So with this ray down here, my endpoint is point B, and the direction it's going is towards A, so I'd write BA, and then I put an arrow over the top going from B to A in that direction. So this is a great way to name it, but I cannot name it right here. I can't name it AB. I cannot name it AB with the arrow going backwards. This is the only way to name this ray. There are no other options here. I also can't name it B arrow. That doesn't tell me the direction the ray is going. So I want you guys now to pause and draw an example. Pause, answer some questions, draw an example. The next type of item we're going to look at are line segments. We name a line segment by naming its endpoints, and we draw a bar above to indicate above the 2 letters of the endpoints, like a line without arrows. So for example, we would write segment AB, and we'd say out loud segment AB if we had this specific segment, AB. So to name this, I could call this guy BA, or I could call it AB. Both are okay. The order doesn't matter. What I cannot do is name it by 1 letter. We can't do that, okay? That's not okay. We have line segments, and we also talk about lengths of line segments, and we actually have different notations for the length of the line segment and the actual object that is the line segment. If I write AB with no bar, just like right there, we would say out loud the measure of AB or length AB. You can sometimes see more formal notation such as M of AB bar, which means the measure of AB, or absolute value, AB with a bar over it, absolute value bars denote length. But I want you to take a minute and answer, how is this notation different from line segment notation? Take a minute below and answer that question. AB with a bar over it denotes an object, while AB without a bar over it denotes the measurement of that object. So let's keep going. When we're talking about angles, we're always going to name an angle by naming a point on one side of the angle, then the vertex, then a point on the other side of the angle. We write it by drawing an angle symbol in front of the 3 letters of the points. For example, we would write angle ABC and say out loud angle ABC. If I were to draw that angle, I get from this information that A and C are on the rays and B is the vertex. Now I could have put A up here and C down here, but I know B is the vertex. The vertex must be the middle letter. So I could name this angle 2 ways. Actually 3 ways. This angle could be ABC. It could also be named CBA. And because this is the only version of this angle, I could also call this angle angle B. We can name it with only 1 letter if that vertex is the vertex of the only angle present. When can I not do this? If I've got an angle where there are multiple angles sprouting out of this vertex, so let's call this D, E, F, and G, I cannot name anybody angle E because angle E is the vertex of 3 angles. It's okay to say angle DEG or angle GEF because those are different angles, but you cannot name it by just angle E. Whereas over here, that was okay to say just angle B because angle B is the only angle in that picture. All right, let's talk about the measure of an angle. We express the measurement of an angle differently than we express the object that is an angle, kind of like segments. So we would actually write the measure of angle ABC, and out loud we say the measure of angle ABC. So the measure of angle ABC equals a number, would equal something like 20, whereas angle ABC names an object, which doesn't necessarily have to have a measurement associated with it. All right, so let's talk about congruent figures. The symbol for congruence is an equal sign with a tilde on top. We say that 2 segments are congruent, meaning that they are of equal measure or equal length. We would say segment AB is congruent to segment CE. So measures are equal, so like the measure of angle ABC equals the measure of angle DEF, but objects are congruent. So I would say angle ABC is congruent to angle DEF. Okay, this is one of those really funky things in geometry where measures are equal and objects are congruent, and you need to use the correct notation for the correct instances. Similarly with segments, the segment length AB is equal to segment length CD, but segment AB is congruent to segment CD. So this is talking about measurement, so these would be numbers. This is talking about the actual object. So we can even mark congruency on a diagram. We use tick marks to denote congruent segments. All segments with a single tick mark are congruent to each other, and all segments with 2 tick marks are congruent to each other, and so on and so forth. So in this diagram, AB, BD, and DC all have 1 tick mark on them, so they're all congruent to each other, whereas AC and BC have 2 tick marks, so they're congruent to each other, but they're not congruent to the ones with 1 tick mark. Your diagram does not have to be 100% accurate. Placing tick marks means that those segments must be treated as congruent even if your ruler disagrees. So if I give you a really frustrating diagram, if I do something like this, and I say, this is congruent to this, you have to trust that those 2 segments are congruent even if the diagram doesn't look like they actually are. We trust tick marks, we do not trust our diagram. Congruent angles are marked with loops. We draw little arcs at each vertex, and again, things with 1 arc are congruent to each other, and things with 2 arcs are congruent to each other. So angle DAB is congruent to angle DCB. We could even call that angle A is congruent to angle C because they both have 1 tick mark. And ADC is congruent to ABC, or angle D is congruent to angle B because they each have 2 tick marks. But A and B are not congruent to each other. Again, the diagram doesn't have to be accurate. If I place an arc, we must treat those as congruent no matter how funky my diagram looks. We mark right angles by drawing small corners near the vertex of a triangle. The corner should look as much like a right angle as is physically possible. For example, in this diagram, DAB and DCB are both right angles, meaning they both measure 90 degrees. So let's talk about classifying angles. Acute angles are angles that are between 0 and 90 degrees, and if we're just sketching an acute angle, it's less than a corner, right? Less than the corner of your paper. Whereas a right angle is exactly 90 degrees, it is the corner of your paper, right? It makes a right angle. An obtuse angle is between 90 and 180, so it's a larger angle. This guy is O, and it'd be this guy right here. Now, these 2 are the 2 angles you probably haven't seen before. A straight angle is the angle that happens on a straight line. It's this angle right here. It's half a circle, 180 degree angle. It's a straight angle, whereas a reflex angle is an angle that's between 180 and 360 degrees, and it's the angle that happens going around the outside of an acute angle. So this guy here is X degrees, around an acute angle or an obtuse angle. So yes. If an element in a diagram is unmarked, there are a few things that we're able to safely assume. You can assume that any line that looks straight is straight. So if it looks straight, it is straight. We're not going to play that game with you guys. Okay? You can also assume that if 2 lines intersect, they're intersecting in a point, and that is what's happening. They're intersecting in a point. You can assume that the order of your label of points is accurate. So D is between A and C. We can assume that. And if it looks like an angle is formed by 2 line segments or rays, it is. Things that you cannot assume. You cannot assume 2 segments to be congruent even if you measure them. So even if you break out your ruler and you see that AD and DC are the same length, you cannot assume that they are congruent because we haven't marked them as such. One segment may not be assumed to be longer or shorter than the other segment, even if it is drawn that way. A point cannot assume to be the midpoint of a segment, even if it looks that way. Angles may not assume to be right angles, even if they look like they are right angles. When I look at this diagram, EDC could be a right angle, but because I haven't marked it as such, it is not a right angle. And two angles may not assume to be larger, even if you measure them. Oh, sorry, equal, even if you measure them, just like with your segments. Equal or congruent. One angle may not assume to be larger than the other angle, even if you measure it. And angles may not assume to be acute or obtuse. You can't assume anything basically about the measure of those angles. So things you can assume. You can assume things about positions in straight lines and rays. You can't assume anything to do with measurements, like midpoints, right angles, congruent segments, unless if it's marked. All right, guys, this is the end of lesson 1A. Please take a look at the MML, and thank you guys so much.